Alright, let's get this shoe on the road. Let me try this. Okay, I think we're running. Which camera are we going? This one? Hi boys and girls, it's me Butch. My name is Terry, David Silvercloud. I'm not native, just sounds that way. I'm 80 years old. Today is Friday the 14th of February. Valentine's Day, so happy Valentine's Day to all the boys, girls, and boyfriends, girlfriends, and of every stripe and color and all of that. And today is 4:15. I had some screw-ups, so I'm finally getting things working. I think. I hope. So what I'm going to do is talk to you about waves a lot. I'm going to tell you a lot of stuff about my theories. I'm going to ramble a lot, but for those of you who want to get out of here like right away, just came to see like, who the hell is this guy? What's he doing? I'm going to go over here for starters. I think I'm on camera too. Hope so. Alright, camera 2. I'm going to give you the really fast answer of why light bends towards stars. The school book answers that you're going to hear are the Einstein relativity concept, where reality consists of space-time, which is filled with objects, and energy follows the lines of space-time, which are curved by objects within it. So you'll go online and you'll see like a 3D kind of graph pushing down on a rubber kind of sheet, sort of pushing downwards. That's a two-dimensional, even though it's a 3D kind of picture, it's a two-dimensional idea because it's pushing in all directions, all at once, at the same time. So that's the Einstein version. The quantum theory kind of idea is that you can reduce everything to a quantum, which is a particle, or a unit of energy, I should say. A quantum is the amount of energy an electron needs to change its position in the atom, either up or down. If it goes down, it gives up one quantum, and if it goes up, it needs a quantum to do it. So that's just a standard of measurement in quantum physics. And you could have units smaller than a quantum, but they're pretty hard to find because we use electrons to measure, and we have to use wave interference to do that. And I'm not going to go into all of that. So where were we? So in the quantum theory and the other theory besides space-time bending, it is that gravity bends light. In quantum physics, although they don't know what causes it, nobody does, and some people say there is no gravity. Butch says gravity is push, not pull, and I'll talk about that later. But in the quantum physics idea, gravity bends the light. So where are you? You're over here. Gee, I should put you on 2 because then I can see what I'm doing. Well, you are on 2. That's why I'm screwing up here. So if this is a planet over here, or something that's given light, and it's going to traverse behind, say, the sun, Einstein predicted that the light would bend as it got closer to the... This may not be the best way to demonstrate, but I'm trying my best. The light would bend towards the sun. You're observing from over where you are. The light would appear to suddenly... This thing would suddenly shift position or very rapidly change position, because the light that was coming towards you is suddenly being pulled over towards the sun, and the same thing as it goes past, and then it goes back to where it was. So that's the gravitational answer. Butch is telling you that let's throw those under the carpet. Here's what's really happening. I'm going to talk about it in the quantum physics way, like in terms of photons. This is going to be a photon of yellow light. A photon is the diameter across is the wavelength of whatever color it is. And photons can be any size, and they're always measured by the size of their wavelength. So theoretically, there's a gravitational wave photon. So it's not a very good way of talking about things for the uneducated, because confusion abounds everywhere. But basically, at the very smallest of the smallest of the smallest, when we got back to the electron jumping from one orbital to another, that quantum is equal to one photon in the quantum physics world, and its wavelength is the frequency of the electron, or the electrons have no diameter. They're just a point source in time, but it would be equated to their wavelength, which in this case would be the diameter of the electron. So the yellow light photon, in fact, is a wave with a wavelength of yellow, and there's a wave front going across, and we're looking at one point source within that wave front that moved out from somewhere. We don't give a crap from where. Did you get that? So this is part of a wave front. There's a wave rolling across here, and this is just part of a wave. And you're looking at it from the side, and I'm over here looking at it from the side. So there's a wave running across here, and this is just one yellow wavelength of that yellow wave, which extends who knows how far from its point source. The point source could be millions of miles over there. It doesn't matter. This is part of a wave front moving forward. I think I got the point across. I sure hope so. And this is one of the yellow photons in that wavefront. And because it's a photon, it has energy. And because it has energy, it has mass. And because it has mass, it's affected by gravity. And in quantum physics, even though the value is like really, 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 really tiny, it's almost not there. There is because they have to allow for it, because they haven't figured out what is that. That's gravity. So because of that, they would say this mass is being pulled towards the sun. In other words, they're acting towards each other. There's problems we know with that now, because pull doesn't quite work. It causes everything needs to have something to push against, and the fact that we're all moving all at once through space all the time is like, what exactly are we pulling against? And that's where relativity comes from. So we do all our measurements from planet Earth. Everything we're measuring is relative to planet Earth. So if we're moving, even though we moved billions of miles from where we were last year, when we took the measurements last year, they were relative to where we were billions of miles last year, and the same things will probably work for us right now. So I think I've gone past the guys that want to leave and knowing the standard explanations. Gravity, maybe I didn't get to mine. I think I haven't got to mine yet. Okay, my explanation is I don't think this is in a book. I haven't seen it in a book. Yeah, I think you forgot to give your own, David. Okay, so here we go. This is the sun. Let's get it out of here so you can see it better. It's spewing tons and tons and tons of crap out all the time. Am I on the right camera? Well, this camera. There you go. Let's try camera 4. Too much reflection. I'm facing my windows and the sun is over there reflecting over here. Okay, so this is the sun, and it's spewing out just shitloads of crap all the time, which means that the space around the sun is denser. It's got more crap in it than the space out there. So what happens is, remember, there's some source of light going past back here. This is a source of light. It's going to go past here. Let's get closer to you so you can see it. So this source of light is going to, it's going to be sending you light like this, and as it goes close to the sun, the light's suddenly going to bend towards the sun, just like they say it does. But the reason it bends is not the other two reasons. The reason it bends is one of the very basic laws of physics, that a wave bends towards a denser medium. So you got that? There's light coming from here, which is electronic waves, and as they encounter the crap around the sun, they bend in towards the sun and go towards you, and everything like you thought would happen, except it's just the crap around the sun that is causing the electromagnetic waves from the light source to bend towards the denser medium. So if that's in any books, I haven't seen it yet. I remember I went to school 60 years ago, and I just didn't bother to look up. I've never seen that, so I hope it's new, and that's the reason. And I'm telling you, Butch is telling you, so it may not be in a book. So I'm going to ramble on and on about stuff that may or may not be in books for you that want to keep on watching me do whatever I'm doing. What are you doing, David? I go by David too. My name's Butch. My name is David, but I go by Butch. 3, 1, 2, 3. Okay. That camera there, right? Yeah, I think so. Okay, camera 3. Yeah, the light's really bright, eh? The sun's reflecting off a building across the alley over there. I'd show you, but then I'd screw the cameras all up. So, Butch, I'm going to tell you a bit about me. Back when I was really young, back around 1958 or 57, I remember in 1957 looking up the sky so we could see Sputnik 1 going overhead. That's how long ago it was. The first Russian satellite. There was only one. It was Sputnik 1. And you could see it go over where I live, Hamilton, and just after the sunset, they told us where it was going to be, and yep, you could watch it go across. So at that time I lived on the beach strip in Hamilton, Ontario, and they were tearing down houses to build the Skyway Bridge. My dad was really pissed off that he didn't buy our property. They stopped way next to our property, and we moved to a different property. But anyhow, because I was poor, I would go into these houses which are deserted and people just left furniture and all kinds of stuff, and the telephone company left the telephones behind, and I wanted the handsets. So I took 4 or 5 phones just to get the handsets. And what I did with them is I made a little plywood box. I think originally I used cigar boxes, then I upgraded to a little plywood box I made with some toggle switches. And me and my Sea Scout buddies, when we went to summer camp, or any camp, we could run a telephone line between our tents using these handsets and the toggle switches to turn the power off and on. Part 1 of that story. So this was in around 58 or somewhere, 59, I don't remember exactly. And one of my buddies, who I had the hots for and didn't quite get to touch, but we slept a few times in the same bed, but we never did any hanky-panky. I wanted to. His older brother was an electrical engineer of some sort, or technician. He worked on the Canada Dew line, which was an early defense radar line in the north. And he had a stereo, and a stereo in those days was like nobody had a stereo. So he invited us over to his brother's bedroom, and we were listening to his brother's stereo. And his brother walked in. So Big Brother did not freak out. He was in his early 20s. My buddy was like, we were all like 15 or something, and 14, 15. He told us about how stereo was made and how it worked. He was really anxious to teach us something, and we were attentive, particularly me, because I was the nerd of my group of friends. I was the nerd. The guy I had the hots for, he was sort of a nerd too. He was going to follow his brother's footsteps and get into electronics. And then he saw my cigar box or whatever I had and said, well, what's that? So I explained about the telephones because it had a handset attached to it. And so he said, oh, I can teach you how to reduce your telephone line from 2 to 1. I said, great! How? So he taught me how to turn a 1, 2, 3, 4, you're over there. How to make a telephone have only one wire. And you need a transformer, any small transformer would do it. Oops. Since I was ripping radios apart, I had plenty of small little, you kids don't even know what I'm talking about, but the nerds know what I'm talking about. They can be used for a bunch of things, usually with alternating current, and the nerds will know what I'm talking about. And you can also use them to convert alternating or variable direct current into alternating current. And the signal from a carbon microphone is a variable direct current. In other words, it's going up and down in voltage, and the transformer can turn that voltage into an alternating current on the other side. So what one does is put the handset on one side of the transformer, and then on the other side of the transformer, one wire runs to the other telephone, and out of the box you just stick an iron rod into the ground, and the earth becomes your line, because in alternating current, the electrons don't go anywhere, they just vibrate. They don't go anywhere, they're just going like this all the time. They go that way, then that way, that's all they're doing. And if you didn't know that, now you know that. So I'm trying to teach you something. I try to be entertaining as well as educational. YouTube gets all iffy about what I wear, but I'm smart enough to know that a lot of you, that's the only reason you came anyway. And so I was thinking, well, maybe I can inspire some of the nerds out there somehow to do something with you know, you get what I'm getting at, I hope you know what I'm getting at. I'm trying to figure out what camera, well, I guess I should go over to here, give you more of me. I don't know what I'm doing here. 3, there we go. I wanted all of me. Okay, I want to talk about waves for a bit. Everything is a wave, and Butch says that gravity is push not pull, and Butch says that's because Butch says if you could take the universe down to if the universe was just one thing and it had parts, they would all be little parts touching each other forever. And there's sort of an interesting thing, if I can find it here, give me a moment, it's here on my computer somewhere, RGB gyro. So if you could imagine all those balls being those white balls up in the upper left there, touching each other, but you're saying, the balls, yeah, that I sort of get it, but they're sort of wobbly. What's with the space in between? Well, that's getting back to, where were we? Those spaces in between. But the other thing that's very interesting is if you look down at the bottom right there, you'll see tiled gyrobifastigium, and the greeny thing is a gyrobifastigium. Okay, you got that? A gyrobifastigium. And this is a gyro, you see it? This is a gyrobifastigium. It's Johnson solid J26, it's 2 pup tenths back to each. And what's really interesting about the gyrobifastigium is that you can tile the universe with it. And you'll see those on the lower right, those red and goldy colored things, those are tiled gyrobifastigium. And if you look at the picture on the left, that's sort of what you're seeing. Instead of the balls, you're sort of seeing, instead of seeing this, you're seeing it as tiled gyrobifastigium in between the balls. Something like that. I don't know how else to explain it. But if you thought the universe was tiled, I'm going to try and call something else up here if I can find it. If you thought the universe was tiled edge to edge, and there was no space, was something, and there was no space in between, and you had to have a shape. Butch is saying if you froze helium, it would be that shape. And if you look, I have to look at my screen because my eyes aren't good. If you look at the page on the left, in the upper left, you will see 2 interlocking tori, and Butchie-poo, this is what Butch says, those are hydrogen atoms, and they've become somehow interlocked, or that's just the illusion we have in our head. But Butch is saying that what you're seeing in the middle upper, at the top above me up there, those pictures, that's what's really happening at a level smaller, like way below the quark level. But as below, as above, that's why Butchie-poo is saying that the very smallest of whatever it is has to be a sphere. Whether it's a, in its world it's a solid, but in our world it's nothingness. It's just too small to be anything. It's so small we couldn't even detect it, actually. So where am I going with this? As below as above. Why are suns round? Why are things round? That's just the natural scheme of things. That's why the smallest unit, if it could be that way, if we could sort of freeze reality, they would, however you look at it, the smallest unit must be spherical, and there must be spaces in between. And Butch is saying that that's the first division of reality, that these things here, if these were solids and this was space, these things are traveling at 4/3 pi c cubed. That way, like if you and I are in those spaces in between, we are viewing everything at the speed of light. And at the speed of light, there ain't nothing there. But there's balls there, yeah, but they're traveling, whatever is making them up is traveling at 4/3 pi c cubed. That's the formula for the volume of a sphere at the speed of light, and it means that the singularity is everywhere all at once at the same time to us who can only see at the speed of light. At the same time, we think we're seeing a sphere, but actually there's something traveling, there's nothing there but a tiny unit of energy that is traveling so fast that we think it's a sphere. And that type of reality, Butch says, keeps happening, as you get bigger and bigger in reality. And that everything is based on waves. So he says, Butch says, up at the upper top there in the middle, you can see those interlocking tori. Butch says that is helium. Butch is saying that. You won't find it anywhere else. But before I die, I'm recording it in as many places as I can, because I said it's what. If I tell you that's what it is, Butch is saying that's what it is. Prove me wrong. I welcome you proving me wrong. I really welcome you, because I want to learn things, and I bet you can't prove it. Okay, so, and if you look at the picture below those two, the helium, what you will see, I can't point to it, but right, let me see, where would it be? I gotta get close to the screen. Right, oh, I can't quite get there. Oh, I keep forgetting that I'm not inside the computer screen. But at the page you see there, you can see the interlocking tori, and right below it, this is a page out of my book, The Shape of God. You can download a PDF of it for free at theshapeofgod.com. And it's a book I wrote 20 years ago. I can't waste time on that. But Butch says if you could freeze helium, it can't be frozen, but if you could, the shape you see right below it is a stellated, gyrobifastigium. Butch is saying if you could freeze this thing as helium, the electrons that are circling, going in this hole and out there, and in this hole and out there, and circling between, the electrons are orbiting each other in the helium, and they can't get apart because their orbits are entangled. Butch is telling you that. So if it could freeze, it would form. Butch is telling you that. It can't do this, but if it could, the shape right below at the top left page in the middle there is a stellated gyrobifastigium, and you can find that in my book. Okay, where am I going with this? What else do I want to tell you about? More about waves. Nothing ever goes in a circle. You're taught that the Earth, this is becoming really popular. It's in my book, but I wrote that 20 years ago. But now it's really, the idea is really spreading. People are, oh yeah, there's no such thing as traveling in a circle. You have to travel at the speed of light squared to be able to make a circle, a real circle, all at once, like to be everywhere on the surface of that circle at the same time, all at once. You have to be that's where the E equals mc squared things come from, and that's where the 4/3 pi c, like to be everywhere within that sphere I told you about, of the balls. If they could travel at 4/3 pi c cubed, viewed from outside the sphere, viewed from, if the energy, if this is a photon, if the energy is traveling at 4/3 pi c cubed, it'll appear like a yellow ball to me as an observer looking at the speed of light out here, because the energy traveling from there to there can only travel at the speed of light, but this is traveling way, 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 way faster. So sometimes it's there and sometimes it's not there. If we could see at 4/3 pi c cubed, we would see a point source moving. It probably would look like it was standing still. We would just see a tiny point source probably at the center of where this is. I hadn't thought about that one. You got me thinking about something. Okay, where are we? I'm trying to get you all into the idea of waves. So what happens, and because this is going on and on like I do. I told you I was going to go on and on. Where are we? Not that one. Wave motion, not that one. Sorry, I have to look at my screen here. I got to find the right one. Here we are. Okay, let's look at this one. It's coming up. So you can see at the image, my right arm is there. So this is my left arm. The image right over there on the page, it's out of my book, The Shape of God. It's just a beaker of some sort, and I've drawn a helical wave down the side and marked out the months of the year, and you can see that as Earth is going through space, it's making a a helical wave, and you say, going through space, what? Well, Earth is 93 million miles from the Sun, but in 1 year, I have to tell you, Earth moves 7 billion kilometers within the Milky Way in a year, and the Milky Way is moving at over 1 million miles a second, so I don't know what that is in a year. The point is that when Earth is going through space, how can I get this here? When Earth is going through space, and the Earth is circling around it, everything is moving forward, so it's not just making a circle, it's spiraling through space. And you'll find lots of videos now about that. In 1 year, Earth travels 7 billion kilometers within the Milky Way. And so the wavelength of Earth in 1 year is 7 billion kilometers. One wave with an amplitude of 93 million miles, which is what, 43 million miles, kilometers. I'm not good at I'm old school, I'm 80. Anyhow, you get the drift. It's only 93 million miles high, but I know it's 7 billion kilometers long because on the page on, let me get that way. I gotta see myself. The other way. That way. The page over there is an email from Karen Masters, who's an astronomer. Because when I was writing my book and I thought about all this stuff, I thought, is that right? So I wrote and asked her, and I don't know if she'd thought about it before, and she said, oh yeah, you're right. She didn't say I was right. She just tells me what the motions are. She did the math. Yeah, so Earth makes a helical wave through space once a year. And this is all about, I'm trying to get you thinking about everything is a wave. Nothing is not a wave. What have I not covered? Because I've been going on and on and on. Waves can be two-dimensional, like you see in the surface of the water between the water and the air, or waves can be three-dimensional. So there's all kinds of waves. Like if you're doing a skipping rope up and down, that's a wave. But if you're a radio antenna broadcasting, the wave goes out spherically from the antenna. And just so I don't know, I just want you to be able to see me here. Let me see. I gotta click that button too. Gotta do that first. Okay. So in quantum physics, everything can be reduced to a wave, and a ball can be reduced to a wave, and that's very handy because that's where we can get into reducing light to balls of energy, and that's part of where the gravitational answer, I might have talked about this already, the gravitational answer of why does light bend towards the sun, it's, well, if the photon is energy, we could call that mass, and since we have to allow for gravity somewhere, that's what does the pulling. Butch says, yeah, well, it's going to happen, but for other reasons, and Butch says it's because waves bend towards the denser medium. So a photon doesn't bend, the wave bends. This is just one point source of a yellow photon in a yellow wave front moving across from here to here. It's a yellow light extending up and down too, back and forth, but this is just of that giant wave rolling towards you, which is all yellow. It might be P. It's coming at you. Ah, it's P. But it's a wave. It's like, imagine a big wave out there. It's all yellow. This is one little piece of it, and its distance is the wavelength of a yellow wavelength. So a photon can be any size, but in quantum physics, when you start doing quantum physics, you have to talk about it in relation to the size of an electron, because a quantum is the amount of energy that an electron needs to go up to one higher level of energy in the atom, or it gives up when it goes down, and it takes on or gives up a photon. So the primal photon of photons, the baby photon of photons, is an electron, which we're not going to argue about right now. And you can say, well, what happens if it spins? Right, okay, now we're creating waves. You see, it gets tricky if you don't know what you're talking about. And I'm confusing a lot of you already. I'm trying to get you psyched up into physics and thinking about things you may not have thought about before, and to entertain you. And I hope it covers the things I wanted to cover. Mostly I'm talking about waves. Let's look at my board here to see if I missed anything. Give me a second here while I get over here, while I check out my board. I could go to camera 1 here. Go to camera 1. While I'm checking out my board, I just got to see if I missed anything here. Title, wave motion, did that one, did that one, did that one, did that one. Okay, so I'm going to go back to here, and we'll go over to here. Camera 3. Let's go to camera 3. And I'm going to wrap this up because I'm just rambling now. I hope I gave you food for thought and answered the question so that it's not total clickbait, because I know this is a really long video. I don't care, I'm just making a video and rambling. That the reason light bends towards stars is that electromagnetic waves bend towards the denser medium, and the space around the space around the sun around here is denser than out there, so the waves they bend towards the sun. So I hope you're doing your exercises to stay in shape. A little bit goes a long way. You don't have to do much, but you got to remember to do it regularly. What camera am I on, just to check here? 3. 1, 2, 3. Okay, that'll work. Let's go to camera 4. Hang on. Gotta put that down. So yeah, remember to do some exercises, and these are 15-pounders, and I don't usually do the up above my head ones with these. I usually use my 8-pounders, but the point I'm trying to make is if you want to stay in shape, you're going to have to do something, so do it. It's not going to happen all by itself. What else? I think I covered it. I had something in my head, but I forgot. I'm such a ditz. Okay, I'm going to go back to camera 1 here. And I'm going to... I have to put my glasses on because I can't see worth dick. I like to see dicks, but I can't see worth dick. Gotta be something in there somewhere. Alright, so I think that's it, boys and girls. I'm going to reach over here to stop recording, and I'm going to click it. So, where are we? Bye from Butch.